Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid.
Planetoid.
I love that word.
This episode was first broadcast in 2013.
Hello and welcome to Diffusion. Sit back and relax while we inject weird and wonderful science directly into your brain. I'm Ian Wolfe. On this edition, stem cells heal damaged corneas. Build your own robots. But first up, here's the news. Would you trust DARPA to implant a remote control device in your brain? The Defense Advanced Research Projects Agency of the USA, DARPA, have proposed a project they call RAM, Restoring Active Memory. DARPA's proposal synopsis starts out innocently enough with, it is desired to develop a prototype implantable neural device that enables recovery of memory in human clinical populations. Veterans returning from war with post-traumatic stress disorder and brain injuries can lose some skills like driving, and it would be useful for them to be able to recover any physical skills they've lost so that they may be returned to active duty without complete retraining. Things get more interesting later in the document, where they express the desire for an exploration of neurobiological and behavioural distinctions between memory function using the implantable device versus natural learning and training. This could mean that they wish to see the difference between an injured person benefiting from a successful device compared to how they would learn new memories on their own. Or could be a comparison between how a healthy person learns with an implant compared to natural learning in someone without an implant. Augmented learning? It could also mean to compare the difference between memories implanted using the device against memories acquired through natural learning and training. Or it could mean all of those things. This could be a new way to deliver training and skills without lengthy education like in The Matrix, or it could be a way to alter existing memories to hide evidence. The problem with post-traumatic stress disorder is not lost memories, but vivid memories that intrude themselves on your mind without warning. How useful if you could change a soldier's traumatic memories. Experiments to insert false memories in mice were successful at MIT in July 2013. The proposal details require developing a computational model of neurobiological mechanisms underlying memory in humans, developing a portable, secure, wireless prototype implantable neural device for restoring memory encoding in human clinical populations, and investigating several types of complex memories in animals to develop computational models to restore memory function. Wireless, remotely controlled memory brain implants? If you can understand neurobiological mechanisms of memory encoding well enough to restore damaged memory, could you also understand it well enough to read it out of the brain from the implant? Could the implant be used for debriefing or even interrogation? The intention is to record brain signals and decode them. DARPA also planned to examine how drug addiction works in the nervous system and how chronic pain and chronic fatigue are processed in the nervous system and the brain. There's the potential for giant leaps in understanding how the brain works and in new treatments for brain injuries and diseases. I can't help but expect that with DARPA in charge instead of hospitals and universities, that a lot of the $100 million funding would end up being used to weaponize the results. Smart Hair by Sony. Wearable computers have moved into wigs. The wearable electronic toupee would give you extra sensors like sonar to help you navigate in the dark. The wig may also have sensors to monitor your health through your skin, with the ability to give you haptic feedback through small vibrations or shocks. It could read your brain activity to let you control a PowerPoint presentation, or even let you communicate silently with another smart wig user with wig-to-wig machine telepathy. Basically, it's a wearable computer that's invisible to other people, that's in direct contact with your head at all times, that will have sensors to tell you things about yourself and the world around you, like whether or not someone's approaching behind you. The wig will also have location sensors to tell if you put it on properly. The patent suggests that in addition to monitoring your health, the wig would be connected to artificial muscles that look like hair. It goes on to suggest that artificial muscles could be used in fake moustaches and hair extensions, which brings on visions of a Medusa wig with independently moving fake hair. The patent suggests that like those Neko cat ears that move when you change your mood by reading your brainwaves, the wig hair could dynamically change when the user is excited. Could that mean that your hairstyle would change automatically to match your mood? Now, if you can just integrate your Sony Smart Wig with your DARPA brain implant, which leads us to prosthetic hands with a sense of touch. 20 spots on prosthetic hands are stimulating peripheral nerves in 2 patients, giving them a sense of touch, thanks to researchers at the Cleveland Veteran Affairs Medical Center and Case Western Reserve University. One man using the prosthetic hand can pick up a cherry and remove the stem without crushing the fruit, because he has a sense of how hard he is gripping. Previously, nerve interfaces degrade the nerves very quickly and stop working, but the prosthetic hand sensors still work after 18 months. 3 nerve bundles in the arm, the radial, median and ulnar, are held in tiny cuffs, which gently flatten them, putting the normally round bundles into a more rectangular configuration to maximize their surface area. 20 electrodes on the 3 cuffs deliver electrical signals to nerve fibers called axons from outside a protective sheath of living cells that surround these nerve fibers. Previous attempts have always penetrated the protective sheath in an attempt to get higher resolution, but they've always ended up degrading the nerves and stopped working after a few weeks. Respecting the protective sheath seems to have gotten them to 18 months and counting. The feel of the nerve signals can be tuned by the person using the prosthetic hand. One of the men has said it sometimes feels like he's touching a ball bearing, other times like he's brushing against cotton balls, sandpaper, or hair. The researchers hope to offer sensitive prosthetic hands on the market within 10 years. Clinical Professor Stephanie Watson is a specialist in corneal surgery and research. She's passionate about research and innovation when it comes to the eye. She works at the Save Sight Institute, which is part of the University of Sydney. She spoke to me about healing damaged corneas with stem cells.
So the cornea is the window to the eye, and on top of the cornea is a layer of very special cells that maintain its clarity, so it allows people to see and also keep a comfortable eye. This layer of cells is generated by stem cells.
There can be vision problems when the stem cells don't renew?
Yeah, so normally every 7 to 10 days, the whole entire surface of the cornea is replenished by the stem cells. When the stem cells don't work properly, the cornea doesn't have a clear surface, so it's a bit like a lens with dirt or rain on it, with say maybe a lens with scratches on it.
So as the stem cells renew the cornea, what happens to the old cells?
They just shed from the surface, so they come off in the tears.
But it can go wrong.
Yeah, it can go terribly wrong, unfortunately, for some patients. And that is either because they have a condition that predisposes them to not making healthy stem cells, and that can be a genetic condition, or the most common cause is actually a work related injury, a chemical injury to the eyes. And some of these injuries can cause severe damage, and particularly to the stem cell region. The other things that can cause stem cell problems are recurrent surgeries on the eye for things like eye tumours, sometimes too much UV radiation, severe infections, and also some very rare scarring conditions.
And what can you do about this?
Well, we developed a technique, it was a world's first technique for transplanting new stem cells onto the eye. And we used a contact lens, and we used the patient's own tissues. So it was a self-treatment. So we were able to grow their own stem cells in their own blood. And we published the results, and we've now looked at the long-term results, which have, had moderate success. And we were able to treat some patients with this. But at the moment, we're in a situation where we're seeking funding to be able to treat further patients.
And so you were applying stem cells that you'd grown in vitro in their blood to a contact lens which then went on their eye?
But we grew the cells on the contact lens. So we took cells off the patient's other healthy eye, or if they had two eyes with stem cell damage, we actually took it from another part of the eye tissue. And when we put it onto the cornea, the eye's window, it actually became clear and behaved like corneal cells. So we took the tissue, we put it onto the contact lens. The cells over 10 days grew out to cover the entire lens, and then we put that lens onto the patient's eye after removing sort of the damaged surface. We took the lens off after about 2 weeks, and when we took the lens off, the cells had transferred from the contact lens onto the patient's eye.
So the cornea was clear after the 2 weeks?
We were able to regenerate the surface layer of the cells. Because a lot of the patients had had other problems with their eyes, they actually had some deeper scarring in the deeper tissue layers, but the majority of patients had improvement of vision and improvement in their surface.
And so these are stem cells that are already specialised for the eye? Or...
Yes, yeah, we were using stem cells that were specialised for the eye. And the advantage of that is that the cornea is one place where you can actually it's a bit like the skin, where you can actually see and harvest the stem cells quite easily.
Right, so it's one of those things that you hear about stem cells is the danger that they can change into other things before you transplant them. Is that a danger with the eye stem cells, or are they already so specialised that they're just going to become part of the cornea?
Yeah, they're already sort of a bit the way down the differentiation pathway, and we didn't see any sign of that in our studies, and nobody's found that around the world in working with this type of stem cell. They're already committed stem cells, so they're committed to become the epithelium or the skin of the eye.
And what do stem cells do in the other part of the eye? You mentioned you can harvest them if the corneas are damaged, both eyes. You can harvest them from other parts of the eye. What do they do there?
Oh, well, the cornea is the clear window, but surrounded by that is white tissue known as conjunctiva. And it has also regenerated the surface layer. And so there's conjunctival stem cells. And so they provide for, a healthy front of the eye.
Can you tell me more about putting the stem cells from the contact lenses into the eye and keeping them alive?
So you have to envisage that the front surface of the eye is a bit like a garden. And the stem cells are the seeds. And then we have the tears are like the rain, and the soil is actually the specialised environment that stem cells like to live in. And so when we transplant those seeds, we actually need to ensure we're putting them into the right soil. And so part of our work is trying to make sure that we've got the right fertiliser, the right type of soil, that it's getting enough sun. So, unfortunately, if we can't, if we don't have the right sort of tools in our garden and the right soil, then the stem cells that we put on might not survive as long as we would have hoped. Well, what we're trying to do is look at ways to do the technique more efficiently. Since we reported the technique, there's other groups around the world that have been working on our research, trying to develop it further. And basically the next step is to try to get the treatment available to a larger patient group, or get the treatment, to make sure the treatment is available for patients. And that's probably our biggest hurdle, because stem cell treatments are very expensive. And we're currently doing a survey all around Australia and New Zealand to find out how many patients have stem cell deficiency of the front of the eye. And we're hoping that will give us some information then to be able to try to get some further funding to be able to provide this treatment for patients that are currently suffering with poor vision and uncomfortable eyes due to their stem cell failure.
Would that be something that you would persuade the government to fund with Medicare?
Well, the patient numbers that are affected, aren't huge, and so we don't believe the Medicare would pay for it, and the procedures are very expensive. What makes it expensive is having to have a specialised lab and have that lab meet certain very specific requirements. And so we would, need funding to cover that. And I don't think the Medicare system would currently take that on, unfortunately. I guess just to say, as I said before, that the most common people to get stem cell injury are patients from chemical injuries at work, and this group of patients generally tends to be a young patient, and the effects on the eyes can be devastating. And so we really do need to get these stem cell treatments out to the people, and look at ways of doing that.
What sort of chemicals in the workplace can cause these injuries?
It's basically alkali. Alkalis do more damage than acid. We have seen patients who have had damage to their eyes from cleaning beer lines. Beer lines are cleaned with a particularly toxic and highly alkaline substance, and they're cleaned under pressure. And so when there's an accident, that very high pressure alkali is actually ejected into the patient's eye, and it does a lot of damage.
A beer line.
Yeah, putting beer lines in pubs. So in order for beers to taste good, the lines that the beer's delivered through need to be cleaned regularly. And there's various ways that it is done, but some of the ways are actually quite risky for the person doing it.
Gee, we knew beer was dangerous, but we didn't know it would hurt your eyes.
That's right. So we've currently got a report in that we're hoping will be accepted by one of the major journals in Australia to report this as an issue and to advise, workers that they need to protect the eyes. Yeah. So stem cells actually have to live in a specialised environment. It's known as a niche. So when we transplant the stem cells, we need to actually also look at, well, where are they going to go? Are they going to go to the specialised environment, to the niche? And so part of our research is also looking at the special proteins in the niche. And we actually found that our contact lenses actually had a protein on them that was similar to that found in the niche. So we're also looking as well as providing more stem cells, we're also looking at how to keep them healthy by providing the right factors, the right proteins, the right growth factors and vitamins for the stem cells.
Professor Stephanie Watson, thank you very much.
No, thank you. Thank you.
That was Clinical Professor Stephanie Watson from the Save Sight Institute at the University of Sydney, talking about healing eyes with damaged corneas.
You're listening to Ian Wolfe on Diffusion Science Radio. Send emails to science.diffusionradio.com. We're brought to you across Australia on the Community Radio Network and podcast over the internet on diffusionradio.com.
The Sydney Mini Maker Fair at the Powerhouse Museum had robots. RoboGals teaches schoolgirls to make robots from Lego Mindstorms.
Hi, my name is Pete and I'm from RoboGals, UNSW. So basically, RoboGals is a non-profitable organization and we hold robotics workshops using Lego Mindstorm. And we do this to promote and encourage girls to do engineering from high school. We go to high school as well and hold workshops there, and sometimes the school comes to uni to run workshops as well.
And it's all with the Lego Mindstorms?
Yep, it's mostly running using the Lego Mindstorm. We're looking to hold more Arduino workshops as well, but we're just getting to that.
Right, and the Arduino is a microcontroller that it's easy to program.
Yep, it's simple to program. We are looking to just having it running the basic because mainly we're targeting girls who's around 10 years old or maybe above that, but still in high school.
Okay. And where should people look online for RoboGals?
If you would like to look online for RoboGals, visit us at worldwideweb.sydney.robogals.org.au.
Well, thank you very much.
You're welcome. Thank you.
And next, Stephen Martin from BotBits spoke about kits for combat robots that duke it out in the arena.
G'day, so I'm Stephen Martin from BotBits. We're a group of guys who make combat robot parts in Australia.
And so you're making, you're making parts for people to make their own robots that battle each other.
Pretty much. We do speed controllers mostly, but we also do these little kits here. So we do parts for the 150 gram class, for the 1.36 kilo class, and the bigger 13.6 kilo class as well. So we do a range of things.
And it looks like the bots you've got on display here look like they're very much 3D printed.
Yeah, so these are our 3D printed kits. We call them Green Ants. So on display we've got some of the ones I made for the national competition of the Ipswich Art Gallery. But these are kits you can also buy yourself and put together.
And how long do you think it would take someone to put together one of these kits?
So about an hour if you have a bit of RC experience. If not, there's a bit of background that you sort of need. But they were sort of designed to be able to be put together by children with adult supervision.
So there's no soldering?
There's no soldering. You need a Phillips head screwdriver. That's the only tool you need to put them all together.
Wow. And so these robots, what are the different ways that they fight each other?
So these ones here are flippers. They're designed to flip the other opponent over onto their back. But you can have saws and spinning blades and lots of different things. It's only really limited by the rules and your creativity.
And there are regular competitions for Robot Wars?
Yes, there are. So there's competitions in Sydney and also in Brisbane. We run a competition for either the little ones or the big ones, so 150 grams or 13.6 kilos every couple of months.
Every couple of months?
Yeah.
So where do you run the competitions?
So I'm from Brisbane myself, so we run them around, so some from inner city Brisbane, Ipswich, Toowoomba, all sort of around that area. So we do a bit of travelling around because people are fairly spread out over Queensland too.
Do you know if any are run in Sydney?
So there is some in Sydney, not quite as regular as us in Queensland. New South Wales Robot Fighting Club is the name of the club in Sydney. There was the Robot Wars Sydney, which I came down for a couple of months ago over at Redfern.
And there's National Robo Wars as well?
Yep, so the Robot Wars Nationals, I organised that competition. That was run a couple of months ago up at the Ipswich Art Gallery. We had about 20 of the featherweights, so the 13.6 kilo robots, and about 20 of these little 150 gram robots as well. So it was a massive competition over 2 days.
So if people want to find out more about Robot Wars and about your, what are they called, your
kit robots and robot parts. So our little company is botbits.com, so BOTBITZ. And if you want more information about competing in combat in general, robowars.org is the place to go. So we have a forum on there where all these events get organised and we talk about things. You can ask questions and learn how to build one yourself.
Stephen, thank you very much.
No worries, nice to meet you.
Once your robot has been destroyed in battle, you can build a better one by buying new parts or even a new kit from botbits.com. You can find out more about RoboWars at robowars.org. Diarmaid Hera from Robological has developed a platform to let you build your own internet-controlled devices and non-combat robots.
My name is Diarmaid Hera, representing Robological. That's our company, founded with two partners, Christian and Zhang and myself. So we've mostly been in academia for the last 10 odd years. And still Christian is an academic, and we've moved from there. We've worked with a lot of robot artists and kind of odd sort of people in the last 4 or 5 years. So we're building some hardware and software from that knowledge base. So what we are showing today is actually we're developing this microcontroller board. So we've got a number of I/O inputs, so put some 4 motor drivers. And actually has a battery management system, audio amplifier, so you could connect directly to Raspberry Pi or Android platform. And we got software framework already built in, so you could easily program robots and stuff like that. So the idea is that we take the hard kind of level of microcontroller programming out of the user's hands and make it a bit more abstract, so you could connect devices and build interesting Internet of Things, so to speak, between devices with minimal effort.
You could build a robot using your circuit boards and then control it from the internet.
Yep, exactly. So this is actually came out with some of the work we did. It just became apparent that especially for kids, I do a lot of mentoring kids and stuff like that. If something works straight out of the box, then you get curious and you're not disheartened. Like most of the people I've talked to, even today, they said they have a Raspberry Pi at home, but they haven't really get to doing anything. So we want to make that initial excitement kind of come to some products. So without devices, you could just plug in Android device, and you could immediately get a robot working in 10 minutes. And then you could kind of reverse engineer it and do some more interesting stuff afterwards. So that's kind of where we are heading with this.
And if people want to find Robological, where should they look?
We've got a website, robological.com, ROBOLOGICAL.com. And we are launching a Indiegogo campaign for this particular microcontroller and the software framework in about a week's time. So if you just head to our website or ro-buddy.com, that will get you to Indiegogo campaign. And that'll be great if we could get some support there.
And the Maker Fair's only been going for an hour or two. But have you had children interested as well as the adults who play with it?
It's actually mostly children. Straight away, they've got the app working, and it's funny. We had these postcards for the campaign printer. We had about 100. We didn't think that we were gonna get in, and all the kids had just taken one. The parents, and some of them have even given us contact details, and they're saying this is fantastic. Just let us know when it's all launching. So the kids are. That's what I'm saying. That if you have something working straight out of the box, that's when you get excited.
Yes.
And then you get curious. Then they start asking questions how this works, and then you could, gradually get into the deeper layers of programming and things like that. So, yeah, we had really fantastic feedback so far.
Well, thank you very much.
Thank you very much.
To find out more about Robological and building your own internet-controlled devices. Look to ro-buddy.com.
And that's all from us this week on Diffusion. Are you a scientist, artist, biohacker or maker who'd like to be interviewed about your work? Send your contributions, opinions, helpful suggestions and donations to science@diffusionradio.com. That's science@diffusionradio.com. Please rate the show on iTunes and Spotify. Tell your friends. Follow me on Instagram, Twitter and Mastodon @IanWolf. The news music was Rhinos Theme by Kevin MacLeod of Incompetech.com. I produce Diffusion, which is broadcast around Australia to 28 stations on the Community Radio Network, including Tune FM at the University of Armidale in New South Wales, 2MVR in Nambucca Valley, 3MBR in the Mallee Border districts of Victoria and South Australia, 4DDD in Dalby and the Darling Downs in Queensland, 4RPH in Brisbane, Denmark FM in Western Australia, 6GME in Goolarri in Broome, Radio Adelaide in South Australia, Lofty FM in the Adelaide Hills, 2XX FM in Canberra, City Park Radio 7LTN in Launceston, Tasmania, and Print Radio in Hobart. Diffusion is narrowcast on Indigo FM 88 in Northeast Victoria. Subscribe to the podcast on the Diffusion website, www.diffusionradio.com. That's www.diffusionradio.com, and check the website for links, photos and videos about this week's show. If you enjoyed this show, you can explore more than 1,300 previous episodes archived on diffusionradio.com, where the shows are labelled by keywords, so you can focus in on the stories you want to hear. I'm Ian Wolf. Join us inside your audio device of choice for more science wondering next week on Diffusion Science Radio.
Science is fun. It helps you to learn, to know, and to appreciate. When you study science, you may go on field trips. You discover the marvelous interrelationships between all living things. You learn to read the history of the Earth as it is written in rocks and fossils. You find out what makes things tick. Everything from a molecule to a living organism. In the study of science is found the most useful and satisfying knowledge of man. Knowledge of his physical world, its past, its present, and its future. And in your moments of relaxation, now and in the years to come, you will find the study of science leading you into fascinating pursuits. Photography, collecting. Why study science? Study science because you will find in the study of science a richer, more rewarding life.